All right, we're gonna try something here. I'm at the school. I've got the iPad set up, recording this whiteboard that's on the desk. We're gonna learn about relative motion. That's typically how we start grade 11 physics because we feel it's intuitive and it sets us up nicely for some cool concepts you're gonna have to learn in physics. The idea behind relative motion, obviously, is that all motion is relative. So let's get something moving. I'm gonna put this guy here. We're gonna call him Albert. He's just chilling out, just sitting there. I've got this toy car. It's kind of beat up, but it should work good enough for what we're doing today. I'm gonna let the car go, and I'm gonna say that that car is moving at 2. It should have some units, so we're gonna say that that's 2 kilometers per hour. It isn't really, but it doesn't really matter what it's going. We'll just call this 2 kilometers per hour. Even though you haven't really learned any physics, everybody kind of knows kilometers per hour by now from driving a car or whatever. So let's just say that this car is going at 2 kilometers per hour. Now here's where we'll add something to it. All motion is relative, which means we have to state what the 2 kilometers are relative to. So what that means is my buddy Albert down here, if he could look at the car, he would say that the car is moving 2 kilometers per hour relative to him. If the car was close enough and he could sort of reach out his hand and high five the car as he drove by, he would feel that high five at 2 kilometers per hour. So the motion of the car is 2 kilometers per hour relative to Albert. And Albert's just chilling, hanging out on the ground. Where relative motion gets interesting is we can consider the exact same motion, but from the other perspective. So what I mean by that is, what if instead of thinking about what the car looks like to Albert as Albert's chilling out there, what if we flip perspective and jump into the frame of reference or the perspective of someone riding in the car? So I'm gonna add a person to the car. Magnet isn't sticking too square. We're gonna call this person Marie. Marie's riding in the car. She could argue that she's not moving. If she reaches out and taps the car, she doesn't feel the car going at 2 kilometers. When she goes to adjust the radio in her car, it's not like the knob of the radio is moving at 2 kilometers per hour. Everything in that car is standing still relative to her. When she looks out the window, she's not cooperating too much, but if she looks out the window, she would say that she's standing still, but she sees Albert as moving at 2 kilometers per hour. If she could reach her hand out and give Albert a high five as they pass each other, she would feel a high five from Albert at the same number, 2 kilometers per hour. Albert would say he's standing still, and Marie moved by at a speed of 2 kilometers per hour going to the right. Marie could just as easily argue that she's standing still, but when she looks at Albert, Albert's moving at 2 kilometers per hour, but to the left. That's our first point of relative motion. We can jump from one reference frame to another, one perspective to another. When we do that, we should see the same speeds, the same numbers, the same units, just opposite directions. Albert would say she's going 2 to the right. She would say, no, I'm standing still, you're going 2 to the left. If Marie had some sort of cool physics equipment, this is just a pen lid, but say she had like a radar gun, she could point the radar gun at Albert and do a little science experiment, and from an experiment prove that Albert's moving 2. Point the same hardware at herself, do the same experiment, point at the car's now moving, but when she points the gun, this radar gun thing at Albert, she could say that Albert's moving 2 to the left. If Albert had the cool radar gun equipment, hold on to the gun, Albert. Let's pretend Albert's holding on, he's being difficult. If Albert had the same gun, he could point it at Marie and say that Marie is moving 2 kilometers per hour. She happens to be going to the right. If Albert pointed the cool radar gun at himself, it would read a value of 0. So from a kind of a logic perspective and from an experiment perspective, we can say that the motions are relative. They both see the same value. They just happen to see it in opposite directions. We'll pause there.